Jenks from Buenos Labs. I'm a DevRel. We're building Bitcoin native applications that intend to make a Bitcoin more productive than an idle asset. Today at ETHGlobal Buenos Aires, I would like to introduce you Trustless Bitcoin vaults that are built specifically for Ethereum developers and for DeFi purposes. We call it Bitcoin Charge Ethereum DeFi. What we are trying to do is to unlock BTC for DeFi participation. BTC Trustless Vault is our solution. We'll give you an overview and differences between the existing Bitcoin solutions and Trustless Vault. This product is being developed actively and is in audit phase. So therefore, I cannot show you any code or ask you to build on it, but we would like you to contribute your idea by following some proof of concept that we did in the Ethereum mainnet and Bitcoin mainnet recently. It's quite exciting. Now, the size of the market, I have to justify the business here for you. BTC market is big. However, it is not as big as the Ethereum DeFi market. It is currently sitting at around $36 billion, assuming 2% of the Bitcoin is used in DeFi. This is underrepresented because the entire BTC market could be as big as $1.82 trillion, and a large majority of it is sitting idle. This is because of a few reasons, and one of them is the trust assumptions in the existing bridges and custodian solutions. There is also technical limitation why it didn't happen, because there is no smart contract capabilities on Bitcoin, and various development to make it happen is going very slowly. So Bitcoin holders are afraid of losing their token when they are involved in these projects, therefore no DeFi participation. Yield on DeFi is very, very low. Yield on Bitcoin is very, very low. We intend to change that. So Bitcoin is trustless. Ethereum is trustless, mostly. However, what is connecting Bitcoin and Ethereum right now is not such a case. The existing wrap solution and bridge BTC will need to go through centralized entities or use a project to make it happen. So our challenge statement to ourselves is, how can we make Bitcoins participate trustlessly in Ethereum smart contract? And we know that in Ethereum world, developers will only want to deal with Ethereum smart contracts and not peripheral challenges, such as running nodes or off-chain networks. So we have researched on this extensively earlier this year, and we've decided to settle on a Trustless Bitcoin Vault product. This white paper explained how Bitcoin can be used on Ethereum DeFi by trusting only the underlying trust assumptions of Bitcoin blockchain, the Ethereum blockchain, and a lot of cryptographic math methods. On a very high level, put it in one sentence, the Trustless Bitcoin Vault is a programmable Bitcoin UTXO with conditional spending enforced by cryptographic proofs. How does it work? When Bitcoin is locked on Bitcoin chain using UTXO and Taproot script, we can make the other chain, Ethereum chain in this case, aware of this event and create BTC Vault object, which are metadatas connected to certain application. The application could be a lending app, the application could be an insurance app, or prediction market. This is then utilized, and the assets can be created on the target application on Ethereum and use the locked position on Bitcoin. Users don't immediately get an asset to trade, but we're making Ethereum dApps aware of this situation, so they can provide a DeFi product to the users. How it looks like is it has three parts of architecture. We have the Bitcoin layer, which allows users to register and create vaults. It also allows users to redeem the vaults, which means getting your Bitcoin back in full or partially by just using Taproot script. And there is another layer between Ethereum and Bitcoin. We call them off-chain actors. They are mainly composed of vault providers who helps Ethereum dApps to establish vaults on Bitcoin and being used, and also challengers whose jobs are validating all the events that happens on Ethereum and Bitcoin to see if the vault providers and other participants in this off-chain actor ecosystem are doing honest work. And on the Ethereum side, we have a BTC Vault Manager, centralized smart contract or single smart contract to keep a registry of all the vaults and also applications. So when a user like Alice would like to lock her BTC and use it on Ethereum to get perhaps a loan out for USDC for her to trade, she can do this with minimum amount of hassle. She just needs to approve a bunch of transactions on Bitcoin and also use her Ethereum wallet to approve a bunch of transactions. And the off-chain actors will use their infrastructure to make it happen. This also means that you as an Ethereum developer creating your dApp only needs to integrate with the BTC Vault Manager layer. All of the front end and stuff can be done by either the application you work with, like the platform you rely on, or you directly use Babylon built front end to interact with the wallets. A very important point to get here is that you need to switch from the wrapped token mindset or bridge token mindset to a different one. We're creating a completely new primitive for it. Traditionally, in BTC bridging or wrapping, you have BTC locked on Bitcoin. You get a wrapped token immediately to be used anywhere in the DeFi application. And all you have to do is just to burn the token before getting the BTC back on the other end. The correct mental model should be changed a little bit. Instead of a direct asset that you get, user selects app and lock BTC. What they get is only a registration of this thing happened. So we call it BTC Vault object, which is the metadata that lives on Ethereum that is being validated. The application can use this information to do whatever they want. For example, a lending app could create some token assets, no matter the standards is, and use it for their own purposes. A lending product will need to have repayment or liquidation occurring. Insurance have expire or being claimed. So these status can be defined by the DeFi application themselves. The critical thing here is each BTC vault must be used in full amount only. There is no partial amount of vault, at least it's not developed right now. One vault equals to one atomic unit, and the vault can only be used in one application at a time. So if you create it for Morpho, you can't use the same vault for Aave. The key points here is don't split the vault amount, and BTC vault is an object. It's not tradable token like a ERC20, and you should not treat it the same way either. So what can you build with this? We're hoping to see lending protocol taking advantage of this. So if I have $1 million worth of Bitcoin, I can lock it and get 500,000 USDC out to do some trading or some more productive use of my Bitcoin. Stablecoin projects can rely on this and issue more stablecoin. Insurance can use this to think of some very interesting DeFi applications to ensure that people are trading and doing DeFi safely. Perpetual, escrow, derivatives are all possibilities. What we want in this hackathon is for you to think of innovative ways to use this vault. Without building to it, you can demonstrate using dummy smart contracts and also front ends to demonstrate your idea. You can also think of ways to integrate the BTC vault, hypothetically, to popular DeFi protocols. So we can run kind of an ideathon on this, and I will explain the price structure later. The proof of concept, Bitcoin, to prove the concept, we have done a Bitcoin lending and insurance architecture. If you think about Bitcoin-backed lending, the borrower just need to lock a BTC up, and then the borrower will get a loan back in Ethereum side. When everything goes all right, the loan gets repaid, the borrower will get the BTC back. In unhappy paths, if the BTC price dropped to a lower point, then it will trigger liquidation, or if the user failed to repay loan. The vault is designed to help with this process. For insurance, you have policyholders who lock Bitcoin to ensure something doesn't happen. The insurance either claim or expire naturally, which returns the BTC fully, or if some incident does occur, a payout will be issued to an underwriter. This is all done natively in BTC. So recently we have done an exciting experiment on Bitcoin mainnet and Ethereum mainnet on October 15th. We have successfully created a, it should be 2025 here. We have successfully created a deposit flow from Ethereum mainnet using Babylon developed scripts, and also test vault providers and liquidators to make different flows happen. So the deposit flow we tested with 9,000 Satoshis, which is roughly about $8. And on Morpho side, because Morpho is a great platform and open sourced and great education program, etc. We love Morpho so much. We decided to use it for our test. The user is able to get 1 USDC from Morpho contract. The vault status undergoes certain changes. When the user submits the request on Ethereum, the off-chain actors will detect the event, create transaction graphs, and create a different kind of Bitcoin transactions in different scenarios. And the liquidators will also create their transactions as well, pre-sign their portions. And on Ethereum, the vault providers and all liquidators acknowledge this, and together they will update the vault status from pending to verified. And eventually the application gets to define their active state back on the Ethereum side. And in this case, Morpho decided to use active in use. So this means the BTC is locked and able to be used, and the application can issue a loan if they want to. In a repayment flow, the user repays the debt on the Ethereum side. The application will detect if it is being done full, and application can destroy the asset that shows that the, for example, in this case, Morpho used ERC20, a Vault BTC token. The Morpho decided to burn the Vault BTC token before calling the system to update the Vault status to redeemed. This way will allow the BTC side to release the BTC. However, user is not able to get it right away. There will be a challenge period for roughly around 2 to 3 days. We're still optimizing the protocol for it. When the challenge are all passed, so the challengers will in this system will be able to challenge the transactions and the immediate event. Once everything is passed, the user can safely withdraw or redeem their BTC. The liquidation flow is very similar to withdrawal flow, except in this case, on a successful challenge, the liquidators will instead get the BTC. The liquidators will have to repay the debt for the user. So let's say the user is not able to repay, or the price has dropped to below margin call level. Liquidators will spot this opportunity and start to request for liquidation. The system will check whether indeed is meeting the liquidation condition. Proofs will be generated, and different actors in the off-chain system will be confirming this event, and it will enter into a liquidation challenge period for 2 to 3 days. If there's no challenge, then the liquidators will get the BTC and instead of the borrower. So in any case, someone has to initiate it on the Ethereum side, and it gets challenged and proved on the Bitcoin side, all using zero-knowledge proofs. So in the challenge phase specifically, any challenger, liquidators, or vault provider can challenge if they think the proof is not valid. If there is no challenge, then the process will continue. If there's any challenge, the BVM3 dispute resolution kicks in on Bitcoin to validate the Ethereum state. So the BVM resolution state is specifically designed to stop the actor from getting this. So different kind of proofs will be created, and we're using something called a Gobble circuit to evaluate who is able to create a valid proof. So if challenge was successful, then there's an initial bond that's being created at the vault creation stage to be issued to the challenger as reward. This is done by revealing secrets cryptographically. If a valid proof is detected, challenger is at loss. Liquidation or borrowing occurs, or in this case it's a redeem process. So borrowers is trying to redeem the thing. If the invalid proof is detected or proven, the challenger wins, and the liquidation or the redemption does not occur. Instead, the challenger will get paid a small amount of bond. So this process does not happen successfully. So I hope that gives you an idea of one example of how this vault product can be used. The conclusion here is crypto economy today between Bitcoin and Ethereum highly reliant on centralized trust assumptions. What we're trying to change is by connecting smart contracts and applications directly from Ethereum to trustless vaults. So we want to have the crypto economy to be supercharged, and more importantly, Ethereum DeFi to be supercharged by Bitcoin and native Bitcoin. By having a trustless Bitcoin vault, we believe that we can attract billions of assets to be injected into Ethereum. So the challenge here, we want you to think of new DeFi use cases, practical plans of integration, existing DeFi, must have examples, mock-up contracts, and build a front end to demonstrate these use cases. We will select a pool of 10 projects to award these USDCs to. Thank you so much.